So what we're doing here is we're solving for the x squared, or we're solving for the parenthesis. We divide both sides by 4. 144 divided by 4 is 36. How do we get rid of a square? Here's SAT advice for you. You take the square root of it. That's how you get rid of a square. And the square root of 6 is plus or minus 6 because we're solving for an x. The reason why it's plus or minus in this situation is if I plug 6 in for x, 6 squared is 36 times 4 is 144. If I plug negative 6 in for x, negative 6 squared is 36 times 4 is also 144. Both answers work. You have to account for that. Let's get that parenthesis alone. That parenthesis represents one number. And now, how do I get rid of a square? We take the square root of it. So it's x minus 2 equals a plus or minus 3. And then we add 2 to both sides. 2 plus or minus 3 gives me an answer of negative 1 or 5. Now our exponent's higher than 2. So we're not just taking the square root. We're taking whatever the exponent is, and that's the index we're going to use. So first, I've got to get the variable or the parenthesis with the exponent alone. 75 divided by 15 is 5. So we have x to the 4th equals 5. And what I need to do here, actually, keep it a little neater. There we go. I'm going to rewrite the x to the 4th equals 5. I'm going to do it down here. I'm going to take the 4th root of x, and therefore I got to take the 4th root of 5. So my answer is going to be plus or minus, because the index is even, the 4th root of 5. And that's your answer. We've got to start getting comfortable with the fact that that could be your answer. When the index is even, we put a plus minus in front. So we're going to add 1 to both sides. We got to get that. Parentheses alone. So we add 1 to both sides. We divide both sides by 6. X minus 2 to the 5th equals 9. Okay. If I want to get rid of that exponent of 5, I've got to take the 5th root of it. Which means I have to take the 5th root of the other side. Now, the square root of 9 is 3. We don't know the 5th root of 9. So you just leave it. So x minus 2, the 5th root of something raised to the 5th, cancels the exponents. 5 divided by 5 is 1. Equals the 5th root of 9. I add 2 to both sides. 2 plus the 5th root of 9. And that is my answer. I've got to be comfortable with that being an answer now. We're going to isolate the radical. So I divide both sides by 3, and I get the square root of x plus 2 equals 12. Room here. Okay. Now, sorry about that. Now, to get rid of a radical, we square it. And we have to square the other side as well. Remember, it's algebra. Whatever you do to one side, you do to the other. When you square a radical, it disappears if the index matches the exponent. And that's really what we're looking for. I subtract 2 on both sides. 142 is my answer. The second one, same deal. a radical can't equal a negative, but we've got to get the radical alone first before we make that determination. I subtract 2 on both sides. I get negative 40. But when I divide both sides by a negative 4, that negative disappears. So we're left with x minus 3 equals 10. I'm going to square both sides. Squaring the left side gets rid of the radical. X minus 3 equals 100. We add 3 to both sides and we get 103. When it's a cube root, same as a square root, we got to get the cube root alone. The big difference is what exponent I use. If I'm getting rid of the cube root, we need to cube both sides. So if it was a 4th root, you raise both sides to 4. If it was a 5th root, you raise both sides to 5. We're not going to go through every other example that could possibly happen. We've got to recognize whatever that index is, that's what I'm raising both sides to. So this becomes 4x minus 4, and 4 cubed is 64. When I add 4 to both sides, I get 68. I divide 4 on both sides, I get 17. And there's my answer. I'm going to add the square root of 2x minus 8 to the other side. So now I have a problem where I have radicals on both sides. That's going to be easier to deal with because how do we get rid of radicals? Square them. And in this way, we're just squaring both sides. It actually works out very nicely. So we end up with x plus 4 equals 2x minus 8. I subtract x, I get x. I add 8, I get 12. And there's my answer. Now, I can't stress this enough with radicals. You've got to plug the numbers back in and check your work. In the past, that was something you would do to check. What you're going to see on the next problem I give, it's now a necessity. 12 plus 4 is 16. The square root is 16. 2 times 12 is 24 minus 8 is 16. The square root is 16. Both of them are 4 minus 4. 4 minus 4 equals 0, so it must be correct. So we're going to add 4x minus 7 to both sides under the radical. So the square root of 4x minus 7. And we're going to get square root of 3x plus 1 equals the square root of 4x minus 7. We're going to square both sides. And we're left with 3x plus 1 equals 4x minus 7. Subtract 3x on both sides. We're going to add 7 on both sides. And 8 equals x. And that's our answer. Get rid of a radical. We square it. Agreed? What do you think you need to do to the other side then? Square it. Which means you have to square the whole thing. Now on the right side, it's pretty easy. What is x minus 3 squared? That has to be FOILed. So it's x squared minus 6x plus 9 right, equals that 3x minus 5. Now whenever you have a problem where there's an x squared and x and neither one of them cancel out, we have to get them all to one side and factor. So we get x minus 7, x minus 2 when we factor, and my answers are 7 and 2. Now, normally, I would ask you to check this work. This has to be done. 7 minus 3 is 4. 3 times 7 is 21, minus 5 is 16. The square root of 16 is 4. So 7 works. But what happens when I put 2 in? 2 minus 3 is negative 1, yet 3 times 2 is 6 minus 5. What's the square root of 1? 1. Negative 1 doesn't equal 1. We call this an extraneous solution. So your only answer here is 7. You do need to account for that.